Hello and welcome to another video. Today we're going to be continuing on with the TypeScript line 75 and we're going to be doing maximum subarray. And so in this problem you're given an integer array and you want to find the subarray with the largest sum and return the sum. And essentially in this solution they're saying this is the one and the sum is 6. Yeah. So this problem is pretty straightforward once you know the algorithm for it, and we're going to go through it, and let's just go through the rest of these. So this one is sum 1. And then this whole thing is sum 23. Okay, we're going to focus on this big array, and we are going to figure out how to do that. And I'm going to show you like a really basic algorithm you can use to get this kind of problem. And it's called Kadane's algorithm. So we're going to go through it. Okay, so we're going to have an array, and we are going to have numbers here, 3, 4, -1. 2, 1, -5, 4. And now we're going to have some other stuff, so let's just show that. So what you want to do is you want to initialize a result value, and you're going to make that -infinity because you're trying to maximize it. And you're going to initialize a current value, and you're also going to make that -infinity. Okay. So essentially, it's a pretty easy algorithm. All you do is you go through the numbers, and then you just check. This is the condition you check. You check if current plus the number is greater than the number. And this pretty much means, will adding this number to my current total help, or should I just start over? And so as we go through this, you're going to see how this works. But let's just go through it. So here, we're going to go over here. This is going to be our number. So num is just the current number you're on, and current is like our current total. So for -2, we're going to say, okay, current is -infinity. Is -infinity plus obviously anything greater than the number? No, it's not. So then we're going to update our current to be -2. And essentially what this is symbolizing is the subarray we're currently using is this one here. Now we're going to come over here and we're going to say, okay, is current plus number greater than number? So current plus number is -2 plus. Essentially, I guess what you can do. No, I think this is the easiest way. You could check like if your current's, yeah, I guess if you could check if your current's negative, that would be another way to check, right? So if your current's negative, just use the new number because adding the current's never going to be good. So we could do it that way, I guess. So I guess but this is fine too. So, yeah. So is current plus number greater than the number? So here, it's going to be current is -2 and the number is 1. And is it greater than 1? No, it's not. Right. So then we're going to say, okay. Then we're going to update our current to be just the new number, which is 1. And now our subarray is this right here. And we're going to come over here and we're going to say, okay, is current plus number greater than number? So basically, anytime current is positive, this is going to be greater, right, as we saw. And anytime current's negative, this is going to be greater. So here we are going to add the number. And by the way, so in our result, every time we're checking a current, we're updating our result, right? So our result should actually be 1 here because we're just maximizing the result with the current. So for every current value, we're just going to say like let result be the biggest value of result or the current value. Okay. So now that we take this, so we are going to take this, right? Because this is greater than just the number itself. So this is our subarray now, and our current after this is -2. And so is the result bigger? No. Okay. Now we're over here. And since our current is negative, remember, anytime our current's negative, we can just get rid of our old array. So now we'll take this new array. And now our current is 4. And our result is bigger, so they're going to update that to 4. Now here, do we want to add this number? Yes, we do, because our current's positive. So we're going to have 3. Then here, do we want to add this number? Yes, we do, because our current's positive. So we're going to have 5. And now our result is bigger, so this is going to be 5. Now do we want to add this number? Yes, we do. Our current's positive. So 6. Then here, do we want to add this number? Yes, we do. And by the way, we're like updating the current number we're on. Yes, we do, because our current's positive. So now we're 1. And then here, do we want to add this number? Yes, we do, because our current's positive. So now we have 5. So you can see that the result is 6 here. And the result 6 was this array over here. But yeah, that's pretty much all you do. So you literally, so we can even rephrase this to check if cur is negative. If yes, cur equals new number. If no, cur equals cur plus number, right? We're just simply trying to maximize, like, do we want to keep extending the current array we're on, or do we want to make a new one? That's all we're doing, really. We just keep extending the current array. So you can see, like, we didn't want to extend this array. It wasn't favorable. We didn't want to extend this array, and then we just kept extending this one. Essentially all you do, and it's called Cadane's algorithm. Pretty straightforward. So let's actually code that up in TypeScript, and we are going to actually code it up directly in LeetCode now. I feel like I'm comfortable enough in TypeScript to know what the errors are without having to, like, read them, even though LeetCode doesn't tell you unless you, like, run the stuff. So, and if it's not strict enough, then we'll just change to and go back to VS Code. But for now, I think we should be good. Okay, so now we're going to have a cur value, as I showed. So we're going to have a cur. It's going to be negative infinity. Then we're going to have a result value. It's going to be negative infinity. And then we're just simply looping through our numbers, right? Pretty straightforward. So we can just say, like, for let num have nums. Let's just loop through them. So what are we doing here? So what we have to check for is current negative, right? So if current's negative, so we can just say that. We can just say, like, okay, cur is less than 0, question mark. And then if it is, then current is going to be the number. We don't need this. Otherwise, cur is going to be cur plus number. Cur. So there we go. We're simply just saying ternary operator is current less than 0. If yes, let's just make it the number. Otherwise, let's keep adding to it because it's positive, so we want to keep adding. Okay, and then finally for result, you just maximize the result. So you just say result equals math.max of result and cur. And that's pretty much it. You just go through it and you maximize the result, and then finally at the end you return result. And let's give that a go. Okay, so you can see it's reasonably efficient, and let's think of the time and space for this one. So for the time, we are looping through our numbers. So that's going to be big O of n, right? We're just making one loop, and that's it. And for the space, we are only using a cur and a res, which are both just variables. We're not making an array or anything, so that's going to be O of 1. And yeah, pretty short problem, Cadane's algorithm. Very good to know, I think. And it will be used for tougher problems that will implement it. So yeah, it's going to be it for this one. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.